Okay, is being taped. Uh, oh, now I know why I'm being kicked out. I have too many windows open here. Okay. Uh, okay. And so what I so I have this file that has all the record number of stars ex lupi, which is right here. Right? Where is it? Most of this data I never published. GQ Loopy I publish. All this data is published, but not the other. Okay, here's ex lupi. So if I do restore star plus, and then I have to add the number 99 somehow. I could put like this, 99 plus dot sav. And then I could add ampersand is a command in IDL that allows you to add another command and tells IDL, say, just wait, don't close yet, I'm going to do something else. And then what I do something else is plot ws. Okay, so what I did is read the number and plot. So if I, and then I could do the same. I go, okay, let me read now the 100. And then I have a different spectra coming in. I don't know if you guys saw. It decreased a little bit. Let me get one in a different night. 315 is a different night. And then you see this is gonna fall. Yeah, see, it's completely changed in a different night. So this star is kind of a craze. So let's say I want to plot all of them in a sequence. So I cannot keep typing 99, 100, 101. It's kind of a crazy. So you could do a program to do all of that, and then you would make the IND that has information 99, 100, 101. I would make this a string variable, and I would call string IND. But I'm not gonna plot. I'm just wanna do something different. I wanna call this string variable, so star plus string ing save, and I wanna print a. So oh no. See what I got. I got everyone there, right? So that's not good because I need one star at a time. So let's say if I print in the first one. Okay, now I have a star, but I have a big empty space there. So IDL doesn't know it's giving the number 99 a double precision integer variable. So I have to take all this space out, and then I think the way it goes is called string a. I'm gonna call this string compress string that thing, remove all. So this is a command to, and I hope it's all right. I think it is. So now with this string compress, and there are several functions in IDL that start with str, and they do a string operation. And I send a list of them to you. In fact, you can go online and do list all IDL string variables or string functions, and it tells you what they do and what you can do with them. So, um, so I create a string for the integer number 099, but it gave me something that I don't want it. So I have to take all these empty spaces and I use this string compress. And now I'm okay. So which means I could now, instead of A, I could say restore A, right? I restore that star, and ampersand, I can do plot WNS. And I have my file there. See, it plot all right. But let's say that I want to plot them all. So I could say for, and the for is a loop. In Fortran, you might know that. So for n changing from 0 to 21. So I'm going to read them all. Do begin. And then instead of end 0, I'm going to put n. So it's going to be varying through the n from 0 to 21. Restore A, plot WS, and I'm going to put a wait 1 second just so I can see what's going on. And 4. See what comes next. So now I'm running through all the data, and I see how they change, over time. And then I could do things. I could plot labels telling the date in which these observations were made. I could try to read the dates. Let's say September 5th, 98, and plot it in there if I need it. But let's say I wanna do more operation. Let's say I wanna read just a small fraction of this data. This line here is H beta, and I wanna read that. So I could, on the plot, I could go back on my up arrow, and I could say comma X range. So the range in which I want to plot is from equal, and then I put in brackets 4,500. Bracket 4,500 to 4,000 or to 5,000. How about that? Or 4,700 maybe to 5,000. Bracket, and the range in Y, I'm not going to put anything in Y. So now I'm reducing the window in R so I can see just a small fraction. This is the garbage that came in there. So now I can see the two lines going in emission. This is H beta, and there is a feature here in H beta that's very interesting. See this absorption here. We are interested in trying to explain how that happened. And then let's say I want to do more. I want to divide by some average here so I can compare a bunch of. I want to plot them all together, and then I can do overplot type of commands. But just saying, this is not a application. I just run this program quickly to have a quick view of the data. I could do that with any other star. I could go to, let's say, TW City Shaw. I don't have a lot of BZ Sagittarius. I have a lot. I think I have that one. Let me see. Restore IND. BZSGR. What's the name? I don't. BZSGR. BZSGR. BZSG. Is there BZ only? Oh yeah. So now I have this BZ Sagittarius that has 69. Look at that, 69 data points. And then I could run through them all. So I'm gonna go back, and instead of going from 0 to 21, I'm gonna go from 0 to 68. And then I can take a look at this entire data point. That's BZ Sagittarius. So the profile changed a little bit. So the wings are kind of yeah, so there is some absorption here, which is interesting. And then it goes away. Anyways, what happened? 68? You didn't like it? I don't understand. It should go to 68. Why didn't it go? Wow. Oh, it's in the BZ. Oh, I see. Should be in the BZ. Anyway, so but you got some idea of what these things are basically.
Okay.
Okay. Oh, I think I did something wrong. Did I? In the BZ. Print in the BZ. Okay, so I have to go. Find. So it's not in this, in the BZ. That was my error. So I have to put in the BZ. Now, there you go. And the H beta is different. It has a double emissions, so there are differences in there. And there is also this red absorption here, which is interesting. And this is a star that I never published anything about it, but it's very interesting. And I look at the ESO, and there is no observations, so we can't do much. It's just a curiosity. I mean, it's gonna take forever, but you could do movies. So if one day we have a website, we could do a blog on the steps we take analyzing data. So instead of thinking about publishing or doing things, we can do a blog and upload results as we go. Um, oh, look at that! See that absorption? That was crazy.
Mm-hmm.
Yeah, it's completely crazy. But anyways, so that's the idea. So the more we get familiar with it, better ideas we have, and then we can, um, you know, make it public as we go. All right.
Mm-hmm.
Okay. So try to get to that stage of doing these plots, um, and I'm taping, so I will generate this video and put in YouTube and send it to you and to Rick too.
Okay.
All right.